everyone, this was my project which me and my friend collaboratively did, and this project name was ContestArena. It was a microservice based uh, project for it is a compilation judge. That means it is a contest platform. It is used to create contests, and also it can be shared to users. They can participate in the contest and test their skills. It is an evaluation platform for multiple users. And the process of creating the contest is, first we need to create some problems. Here there are some problems which I have created, and these are the contests that have been created. And when we click on this create contest, we can create a contest by entering these details, and then by after creating the contest we can also add the questions that are already be there, and or you can add some questions. This was the contest that is lively running, and this was the owner account that have been created with this contest. And when we go to the leaderboard, we can see that there are two users. These two users are the profiles that have been created in multiple browsers of my laptop, and this coder 1 solved this question and this coder 2 also solved. And now I open the coder 2s and I submit another question, and I will show you the live updation of the here. If you see, the coder 2 will be updated lively. See, the coder 2 lively updated, and the leaderboard reflected after the submission is accepted. Next I will demonstrate with another user. If you another that means we will go to the coder 1 and we will submit two questions, and we will see whether it is updating or not. Here the first submission is accepted and the coder 1 have again overtook. And maybe the submission 2 haven't been accepted by this coder 2. You can see the live updation of the score even without reloading the page. I used WebSockets for this feature, and also for sending the submission and handling that. I used Kafka for the communication between multiple services, and used RabbitMQ for the job scheduling of the submissions. And I will show you the process of creating problems. And first, for creating a problem, we need to enter the title, description, input format, output format, constraints, and the type, difficulty of the problem, and base score. And we need to enter the test cases, and if you want to add another test case you can click here and you can add how many test cases you want. This way you can create a problem. And to create a contest you have to click here and add the name of the contest and some description. The description is optional, and you need to schedule it by entering the time and date. It is the start time, and it will be the end time. And the security password is optional. When you click on start, and the contest will be scheduled, and it shows that it will be starting in 3 hours. We can add the problems here. These are the predefined problems that have been kept in the global problem set, and we can assign these questions to this contest. And if you want, we can start this contest now itself by clicking on the start contest. See, this was the contest we have created now, and the users, like this was the user, the coder 2, and in this we can see this contest lively, and we can join this contest by clicking on join now. And now I will show you the code part. This was the whole code part of the contest platform. Okay, first this was the API gateway. This API gateway This Eureka server acts as the central server. It gives the service registry and the load balancing part for this API gateway. And this API gateway handles the load balancing, and also it directs the route. And this was the authentic auth service. It directly deals with the API gateway, and it handles the authentication part and generates a JWT token, and it gives to the API gateway. And the API gateway validates the JWT token every time a request enters. And this was the compilation. This was the basic heart core of the project. In this there are Docker compilers for all of the languages, and this online compiler uses RabbitMQ for asynchronous job scheduling. And there will be a consumer, and I integrated RabbitMQ consumer with the Docker containers using the Spring Boot's process manager, and user Kafka for communication between these microservices. And this is the front end part. This contest service is dealing with the creation of the contest, creation of problems and test cases. And this infra plays a key role. It is creating the Docker containers of RabbitMQ, Zookeeper, Kafka, and also the PostgreSDB. And the leaderboard service, the leaderboard service have Kafka and WebSockets. The Kafka is used for communication with multiple services, and the WebSockets, whenever a new user arrived in the leaderboard or an update is arriving in a leaderboard, it automatically changes and push it through the WebSockets, and the Redis cache is used for storing it temporarily and fast and dynamic updates in the data. Finally, this whole project is highly scalable and easily deployable.